In this lesson, I want to look at the Pythagorean Theorem, perhaps in a new way that we haven't looked at it before. And so let's talk about right triangles and what the Pythagorean Theorem says. Now, I've drawn the picture of a right triangle, but notice I have not used the classical or traditional A, B, and C. And there's a reason why I haven't done that. Why should A, B, and C be universally representative of sides of a triangle? It just makes more sense just to say leg 1, leg 2, and hypotenuse. And that way, in mathematics, I can use A, B, and C for other things, and I don't have to always feel like A, B, and C have to be the sides of a right triangle. So I think it's more correct to use leg 1 and leg 2 and hypotenuse. Now, a right triangle has 2 legs and only 1 hypotenuse. And the hypotenuse, as you can see from the picture, is always going to be the longest side in a right triangle. That's just always true. So let's look at the Pythagorean theorem in a way that perhaps you have not seen it before. Not using A, B, and C, but using what we have from the previous picture. Leg 1 square plus leg 2 square equals the square of the hypotenuse. That's the Pythagorean theorem. And so in other words, if I take both legs, if I square both legs, and I add those numbers, then the result will be the square of the hypotenuse. So I've given some examples here, 3 examples of how to use these in the Pythagorean theorem. So let's look at the first one, 3, 4, 5. I've put 5 in a box on purpose because 5 is the biggest number. Therefore, if I'm going to use these in the Pythagorean theorem, 5 has to represent the hypotenuse. So 3 squared plus 4 squared equals 5 squared. 3 squared is 9, 4 squared is 16, and 5 squared is 25. And look what happens. I get an identity. 25 equals 25. And so therefore I know that 3, 4, and 5 are numbers that satisfy the Pythagorean theorem. Let's look at 7, 24, and 25. Again, do you know why I put 25 in a box? Because it's the largest number there. And so it has to represent the hypotenuse. So 7 squared plus 24 squared is equal to 25 squared. 49 plus 576 equals 625, and I get the identity. An identity is an equation that's always true, no matter what. 625 equals 625. Now the numbers don't always have to be integers, nice whole numbers. So for example, these decimal numbers can work too. 1.5, 2, and 2.5. 1.5 squared plus 2 squared equals 2.5 squared. So 2.25 plus 4 equals 6.25, and I get the identity. 6.25 equals 6.25. Okay. Well, I don't know if you've heard of this term, but we're going to talk about Pythagorean triples. Now, like I said, the numbers that satisfy a Pythagorean equation don't have to be whole numbers. They don't have to be integers. However, there are a certain set of numbers that we call Pythagorean triples. And Pythagorean triples are always integers. They're always whole numbers that satisfy the Pythagorean theorem. So in the examples I just gave you, only the first 2 qualify as Pythagorean triples. Even though the third one works, 1.5 and 2.5 are not integers. Now, in my years as a math teacher, I've encountered that sometimes students have difficulty identifying the hypotenuse. And I've got a couple of ways maybe to help you today to identify the hypotenuse. So let me talk about the most traditional way first. The hypotenuse, by definition, simply by what it is the side opposite the right angle. So here's the right angle, 90 degrees. And so the side opposite is the hypotenuse. So this is the hypotenuse. But when people look at a picture, not everybody sees the same thing, unfortunately, when they look at the same picture. So perhaps this might be another way that would help. Take a right triangle, and if you're having difficulty identifying what the hypotenuse is, imagine making a rectangle out of it. Just imagine. The diagonal of that rectangle will be the hypotenuse. So maybe this way doesn't work for you. Then try and imagine making a rectangle out of the right triangle. And then the diagonal always goes from upper corner to lower corner. It could be going this way depending on how I draw the triangle, but this has to be the hypotenuse. Okay, well let's talk about some very common misconceptions that students have when they work with the Pythagorean theorem.